Okay, so welcome back. And so today we're going to start talking about quadrantal angles, okay? And we're also going to talk about quadrants. So to talk about sketching a graph of an angle, we need to first figure out what quadrant that they're in, okay? So this is the Cartesian plane, right? So we have an XY coordinate plane. And here are the way that the quadrants are numbered. It's numbered counterclockwise, starting with the upper left, or excuse me, upper right quadrant. So this would be 1, 2, 3, and 4. And so the quadrant, or the points actually, will tell you what quadrant it's in. And the angle will also tell you what quadrants they're in. And so the quadrantal angles are the ones that are going to help you determine where other angles are located. It's like the compass of a direction, right? If you know the degrees, you could figure out what direction you're going. Likewise, here in the coordinate plane, we can use the quadrantal angles to help us. Now, what is a quadrantal angle? Okay, that's a good question. So a quadrantal angle is where, again, we're talking about angles in standard form. So it's any angle where the terminal side of the angle lands on one of the axes. So either the positive y-axis, the negative x-axis, or the negative y-axis, or the positive x-axis. So if the terminal side lands anywhere on one of those angles, that's what we call a quadrantal angle. And quadrantal angles do not fall into any of the quadrants, right? So if we have an angle, let's say, that does this, whoops. So if we have an angle that does this, right, and like that, then this would be a quadrant 1 angle. The angle would be in quadrant 1. Or if we have the terminal side over in this way, then we have an angle that terminates in quadrant 2, and so on. Okay? And so that's what we mean by angles in standard form and looking at quadrantal angles. So if we know that a quadrant angle here is 90 degrees, so if we look at the quadrantal angles, right? So if we're here, oops, that would be a 90-degree angle, right? Because it's 1/4 of a circle. And like we said before, 1/4 of a circle is 1/4 of 360 degrees. Oops, not percent. We have 90 degrees, right? And then if we go to all the way to here, right? So if we go all the way to here, where it's a straight angle, so if it's a straight angle, then we go all the way to what? 180 degrees, because it's now half of a circle. And half of 360 degrees is 180. Okay? And then of course if we go another 90 degrees, right? Each quadrant is 90 degrees, right? So if we go 90, 180, 270, 360. Okay? So if I know that an angle is 215 degrees, well, automatically I know that angle has to be in the third quadrant, because 215 degrees is between 180 and 270. Or if I say, hey, the angle is 120 degrees, well, then I know it's got to be in the second quadrant because it's bigger than 90 and less than 180. Okay? Or if it's 540 degrees. Ooh, if it's 540 degrees, well, that's more than 360. So an angle that's 540 degrees goes 360, boom, right? And then it goes what? Well, 540, let's do that one. 540 minus 360, right, gives us what? That gives us 100 and, no. 180, right? And so that brings us back to here, right? So that's a quadrantal angle, okay? Or if I said, hey, what is negative 360, oh, come on, let me think. Let's do negative 412. Okay. Well, now if I go negative 412, guess what? Now I'm going to go this way. So if I'm going negative 412, now I'm going clockwise negative 412 degrees. Well, that's over one circle, right? That's more than 360 degrees. So what I would do is I would take 360 degrees minus what? Or excuse me, I'm sorry. It's 412. So I take 412 degrees minus the 360, right? Because negative 360 is all the way around clockwise. So if I subtract one revolution around the circle, that's going to give me what? That's going to give me 52 degrees. Negative, right? So I'm going to go around, and so negative 52 degrees, guess what? It's going to be in here. So negative 52 degrees is going to be in here. And so, that's how you graph it. So we'll come back and we'll do some more examples. Take care.